So this question I've been getting a lot from everybody, so I figured I'd just go ahead and make a video about it. It seems like a really simple question, but one of the problems is it doesn't have a lot of info in it. So this says, suppose you arrive at a bus stop randomly, so all arrival times are equally likely. The bus arrives every 60 minutes without delay. What's the expected value of your waiting time? So if you go to the view an example or help me solve this, what it says is that for this example, there are 60 minutes that the bus could possibly come. So the probability that it could come would be 1 out of 60 for everything. So let me just pull this up the way it says it. This example says 110 minutes. So let me show you what it's saying. So the event for the waiting time, the shortest waiting time is 0 minutes. The longest waiting time is 110 minutes. Because for this one, it's 110 minutes. So there are 111 values of events, 1 to 110, which is a lot. All arrival times are equally likely, so the probability of the event the bus of any particular time waiting is 1 out of 111. You can actually do 1 out of 110 here, and you'd get pretty close to the same thing. I'll show you what I mean in this other example. Oh, actually, no, you get, that's I don't know why it says 111 there. So what it's doing is it says the expected value, or the first probability would be that there is no wait time, which is 0 times 1 out of 111, plus 1 minute of wait time times 1 out of 111, plus 2 minutes of wait time times the probability, all the way up to 110 minutes of wait time. That's a lot of time. And then they get 55 basically by saying 0 times 1 out of 11 plus 1 times 1 out of 111, which is a lot. So let me show you this example here. So for this one, I could expect there to be a delay anywhere between 0 and 60 minutes. So what I'm going to do, let me put my calculator up really quick. There. Hold on a second, I'll take a minute. Okay, so basically it's going to end up being the same sort of thing. It's going to be 0 times 1 out of 60 in this case because it's 60 minutes. 1 times 1 out of 60 plus 2 times 1 out of 60 plus 3 times 1 out of 60. But I don't want to do all that math. What I'm going to do is just add up all the possible wait times. So I could have anywhere from 1 to 60 minutes of wait time. So I'm going to do 1 plus 2. I'm going to use my 10 key over here. 4 plus 5. Oops. 3 plus 4 plus 5. You just got to be careful here. There's a short way to do this, but I'm just going to do it the long way. Plus 12. You got to be careful not to make mistakes. 13. So I'm going all the way to 60. Hopefully yours doesn't have more than that many. 6, 7, 8. Alright, so I added everything up from 0 to 60. I didn't add the 0 because we know what that is. So I get 1830. Now basically I'm going to multiply everything. I'm going to do it the way the homework says. The probability of any wait time from 0 to 60 is going to be 1 out of 61 because there's 61 possible things that could happen. And again, that comes from the problem. It says there's every 60 minutes without delay. If it was 70, it'd be 71. If it was 75 minutes, it'd be 76, just one more. So I'm going to multiply this sum here by 1 out of 61. So I'm going to multiply. I always like to put parentheses just to be safe. And I get 30. So the average wait time would be 30 minutes. So let's see if that's right. I think it might. Yep, I counted it right. And I actually had done this problem earlier, and instead of dividing by 61, I divided by 60 and got 30.5. So it seems like it's giving you a little plus or minus 0.5 there. But that's how you're going to do this problem. So you add up all the minutes from 1 to however many the minutes are and divide by 1 more than number of minutes, because that's the probability that you have each of those wait time hours. So let me know if you need any more help with that one. Hopefully that answers that question.